Hi, Math 30-1s. Little change of plan. Originally, I was going to start into permutations and combinations, but we did have a math meeting this morning, which is Monday the 6th, and decided to move on to exponents and logarithms first. So this will be the first lesson, obviously, of this section, and a nice start today in the sense that we're just going to do a review of our exponents and exponent laws so that we are ready to deal with laws of logarithms, which is coming in about a week or so. Okay, so just to start today, you'll see down here, okay, that we do have a review of exponent laws. The first thing I do want to point out, though, okay, is right here, okay, that we are talking about powers. Okay, so a power includes both a base and an exponent together. Okay, so a lot of times people will say x to the power of n. Okay, really the technical phrase for that should be x to the exponent of n, so that you'll hear me refer to bases and exponents in that way moving through the chapter. Okay, so just again, I want you to get used to that terminology and make sure you understand what I'm referring to when I speak in that manner. Okay, so when we go through, and I'll start obviously with the product law there. Okay, it says basically that one is indicating that when I am multiplying powers and they have the same base, I am going to add the exponents. Okay, so that becomes x to the exponent of m plus n. With the quotient law, what I'm doing here is I'm dividing powers that have the same base. So in this case, I subtract the exponents. With the power of a power law, okay, the second row here, I have a power raised to another exponent. And in that case, what I'm going to do is I'm going to multiply those exponents together. Now, this doesn't mean that if m is 3 and n is 2 that I now have 32, okay? And that's what some people think because I write them beside each other. It would mean 3 times 2, which would be, in that case, 6. The next law, which says power of a product, okay, I have x, y in brackets, both to the exponent of m, so that m belongs to both the x and the y. So I have x to the exponent of m and y to the exponent of m. Okay, power of a quotient, the next law, same idea. I have x over y, all to the exponent of m, and so that exponent of m belongs to both the x and the y. Okay, and again, just beside it here, okay, where they have y cannot equal 0, okay, again, that's just a restriction to make sure that the denominator is not equal to 0, because if it is, that means I'm dividing by 0, and therefore that whole expression would be undefined. Okay, the integral exponent rule. So this basically, a lot of people refer to as, well, what happens when I have a negative exponent? What we do is we rewrite the base over 1. So for example, 1 over x, and when that moves to the denominator, the exponent now becomes positive. So it's 1 over x to the exponent of m. Okay, and again, where x cannot be equal to 0. So an example in that case, very simply would be like if I had 2 to the exponent of negative 3. Okay, and you'll see that as we move through the chapter, they'll say, evaluate that. Well, because the exponent is negative, that's the same as saying 1 over 2 cubed, okay, which is 1 over 8. Okay, so that's the integral exponent law. Now, rational exponents, okay, basically referring to that your exponent is a rational expression, m over n. Now, I can write that two ways. I can say that this is nth root of x to the exponent of m, and m is underneath of the radical sign. Or I can say it's the nth root of x, okay, all to the exponent of m. Both of those calculations will give me the same numerical value. The second one, okay, this one here, is easier to do in our heads because I'm going to be taking the root of a smaller number and then raising it to the exponent of m after, okay? But the first one will also give you the same value. What you want to notice, though, is basically that when they write it in this form, the denominator of your exponent is what we call the index, okay? It's telling you which root to take of the value, and then at the end, that is where you raise it to the exponent of m in both cases. But the denominator of your exponent is always what we call the index, okay, when I write it as a radical. So hopefully those make sense. You should have seen those before, okay, Math 10, Math 20, and now we're going to use them okay, to complete these questions and, like I said, move forward with exponents and logs in this chapter. Okay, so question 1 says, write each expression without brackets and with positive exponents. So again, two things we have to make sure that we follow here: without brackets and also with positive exponents. Okay, both of those things and criteria need to be met. When I take a look at the first example here in a 1/2 y to the exponent of -6, okay, what you should notice is that exponent of -6 only belongs to the variable y. It does not belong to the 1/2. If they wanted it to belong to the 1/2 as well, there would be brackets around 1/2 y. So that means the negative exponent of 6 must be moved to the denominator. Okay, everything else basically stays the same. So this is 1 over, the 2 is already in the denominator, y, and then to the exponent of 6, okay, in the denominator, like so, and there's your simplified expression. In B, okay, you'll notice there are two negative exponents, okay? So if an exponent is negative, you move that term. Everything else that does not have a negative exponent will stay where it is. So the 5 stays in the numerator, the y is now squared in the numerator, it moves up from the denominator, and the x to the -3 that was in the numerator is now in the denominator. So 5y squared over x cubed is your final expression. In C, I have two brackets here that I'm going to multiply together first, because there are no exponents outside the brackets, and then take a look at what my expression is and then simplify from there. So the first thing I would do is go 4 times 2, okay, and that gives me 8. Next, I would go x cubed times x to the -4, multiplying powers with the same base. You add the exponents. So that would be x to the exponent of -1. And then I would go y times y squared, multiplying powers with the same base. That would give you y cubed. So the only thing that's an issue there is going to be that x to the exponent of -1. So the 8 and the y cubed will remain in the numerator. The x to the exponent of -1 moves to the denominator and is x to the exponent of -1, or just x. Okay, in the denominator, there's your simplified expression. Okay, moving on to D. In D, basically, I will deal with numbers, then I will deal with variables. And what I mean by that is basically I have a fraction here, a rational number, okay? 24 over -4. So what I'm going to do is I'm going to treat that like a fraction and just reduce it to lowest terms. They're both divisible by 4. So you're going to get 6 and -1, okay, when you divide both of them by 4. Then I move on to the variable m. I have m to the exponent of 5 divided by m to the exponent of 4. I'm dividing powers that have the same base, so you would subtract the exponents. 5 minus 4 is 1, so you have m to the exponent of 1. Okay, move on to the variable p. So dividing powers with the same base, subtract the exponents. -3 minus 2 is -5, so you have p to the exponent of -5. Okay, and then lastly, you deal with the q's. So q to the exponent of 4 divided by q to the -2, dividing powers with the same base, subtract the exponents. 4 minus -2 is 6, so I have q to the exponent of 6. Anything with a negative exponent at this point, I will move from numerator to denominator or denominator to numerator. Now, the 6 over -1 is basically just -6, right? That's what happens when you go 6 divided by -1. The m to the exponent of 1 is fine. The p to the -5 will move to the denominator, and the q to the 6 is okay because its exponent is positive. So there is your final expression, okay, in simplified form. In E, okay, moving along, I have to deal with this cube, okay, outside the bracket first. Now, be very careful because when I cube a numerical value, it's very different than cubing an expression that has simply just a variable, and you'll see what I mean here. When I go 3 cubed, a lot of people will write 9, right? 3 times 3 is 9, but that's not what it's saying. It's saying 3 cubed. 3 times 3 times 3. That has a value of 27. Now, when I go x squared cubed, okay, that's x squared times x squared times x squared. That's x to the exponent of 6. And then y cubed, that's y cubed times y cubed times y cubed. That's y to the exponent of 9, right? You're multiplying powers with the same base. You'd add the exponents, 3 plus 3 plus 3. So there's your simplified expression, 27x to the exponent of 6, y to the exponent of 9. All right, last one on this page. Again, very similar to D in the sense that I have a numerator and denominator. I'll deal with the numbers first. So 12 divided by 3, well, they're both divisible by 3, so that would leave me with 4 over 1. And now I have to deal with the variables, which are the b's. So it's b to the exponent of negative 1/2 divided by b. So what am I doing? I'm dividing powers that have the same base, so you subtract the exponents. So I'll just do this on the side here. Subtract the exponents. Negative 1/2 minus 1. So I'm subtracting values, and as soon as I have a denominator, I need a common denominator. So this would be negative 1/2 minus, this would become 2 over 2, right? 1 becomes 2 over 2. So negative 1 minus 2 is negative 3 over 2, like so. So you'll have b to the exponent of negative 3 over 2. It has a negative exponent, so it must move to the denominator. So you'll have 4 all over b to the exponent of 3 over 2. And there is your simplified expression, and we are done with the first page. Okay, hopefully you guys are doing okay with this. Next, simplify the following right answers with, again, positive exponents, okay, nothing negative. In A, again, the first thing I'm going to do, okay, is attach this negative 3, an exponent outside the brackets, to each of the terms or expressions inside of the brackets. So what that means, it looks like this: 4 to the exponent of negative 3, x to the exponent of negative 3, and then this will actually be y to the exponent of positive 6. So what I will do is move anything that has a negative exponent, okay, from numerator to denominator or denominator to numerator. So in this case, the y to the exponent of 6 stays in the numerator, but 4 cubed and x cubed move to the denominator, and then I can actually evaluate 4 cubed. So 4 times 4 times 4, which is 64 x cubed. And there's your simplified expression, okay? Y to the exponent of 6 over 64 x cubed, okay? Now, in B, okay, here's what we can do. Now, one of two things. I can either take this negative 2 and, just like I did in A, apply it to every single thing inside the bracket. Or, here's what we can do as a quicker way. It's basically like a fraction, or it is a fraction, okay, but it's rational, okay, and they're two expressions. They have variables. The whole thing is to a negative 2. So what I can actually do is just interchange the numerator and denominator. So I'll go 4y to the negative 2 and 3x cubed. Don't change anything inside, okay? But now the exponent on the outside is a positive 2, okay? So what I do now is apply the 2 to everything inside. So this would be 16. 4 squared is 16. This would be y to the negative 4. Then I'll have 3 squared, which is 9, and x to the exponent of 6. Okay, and then basically from there, I move anything. Oh, sorry, I better go back here. Okay, I'll go back. So what did I have? I apologize for getting rid of that. 16 y to the negative 4, and then I had 9 x to the exponent of 6. So from there, I will just be taking the negative 4 to the denominator. So I'll have 16 all over, and then 9 x to the exponent of 6, y to the exponent of 4. Okay, and there's your simplified expression. Next group of questions. So without using a calculator, so no calculators, determine the exact value of the following. Now they can ask you to verify with the calculator, but again, we're super smart. We don't need to do that. Okay, we are going to be correct. So here's a very similar question I gave you on the opening page. I have 2 to the negative 3, or 2 to the exponent of negative 3. So that's the same as 1 over 2 cubed. So that's actually 1 over 8. And that's it. There's your exact value of that. In B, okay, I have 81 to the exponent of 3 over 4. So again, because my exponent is rational, the denominator will be the index. This is like taking the 4th root of 81. And that exponent of 3 I can either put inside or outside of the bracket. I choose to put it on the outside because it's just easier to do mentally. So the 4th root of 81 is 3. And then I have to cube it, and 3 cubed is 27. Okay, and there's your answer. 25 to the exponent of 0. Okay, anything to the exponent of 0 is simply just 1. Okay, so there's your answer for that one. Okay, and I'll talk about an exception to that in a second here. Now in D, okay, 16 to the exponent of negative 1/2. So since the exponent is negative, this is going to be 1 over 16 to the exponent of 1/2. Anything raised to the exponent of 1/2 is like taking the square root, and you'll see that here. I go there, and 16. Okay, that index of 2 would go there. Now, normally they won't write the index of 2. When you don't see an index, okay, it's assumed that it is 2. So this is 1 over the square root of 16, which is just 4. Okay. Now, going back to C, okay, this one here, I wanted to just make a note. Now, I had said anything to the exponent of 0 is 1, and that's true to some degree, but here are some cases that we want to be aware of, okay? So, for example, if I have 1 to the exponent of 0, okay, that's 1. If I have negative 1 to the exponent of 0, that is also 1. But if I have this, negative 1 to the exponent of 0, the answer here is actually negative 1, okay? The reason being is that that 0, exponent of 0 here, only belongs to the 1. There are not brackets around the negative 1, so it's like there's a negative 1 in front of the 1. Negative 1 times 1 to the 0, which would give me negative 1. So just be very aware of these three cases, okay? They can be tricky, and I guess especially this one right here, okay? That's the one that could give you some difficulty moving forward. Okay, changing the base. So convert each of the following to the base indicated. So in A, the base I have right now is 9. They want it to be 3. So here's what happens. I take that number 9, and 9 is actually 3 squared. I use the number they want, 3, as the base. So 3 squared, that's my 9. But 9 is still to the exponent of 2x. So I have a power raised to another exponent. So I would multiply the exponents together. And there's my final answer, 3 to the exponent of 4x. So I started with 9 to the exponent of 2x, but now I have 3 to the exponent of 4x and a base of 3, which is what they wanted. Okay, in B. So in B, the base I have right now is 125. They want it to be 5. So 125, excuse me, is actually 5 cubed, isn't it? There's your 125. So there's 125 to the exponent of 2 minus x. Same scenario now, I have a power raised to another exponent, so I'm going to go 5 to the exponent of 3 times 2 is 6, and then 3 times a negative x. So 5 to the exponent of 6 minus 3x, okay, is your change of base answer in B. Okay, C. Now C, you got to be careful because you are multiplying here. So you have 8 and 16, which are your numbers right now. So your numbers right now are 8 and 16. They want both of those to have a base of 2. So 8 is actually what? 8 is 2 cubed, isn't it? 2 times 2 times 2. So there's your 8 times 16 is 2 to the exponent of 4. There's your 16, but it's still to the exponent of x. So what you actually have here is 2 cubed times 2 to the exponent of 4x. Now, using the laws from the first page, we know now we're multiplying powers that have the same base. So in that case, you're going to add the exponents. So this will be 2 to the exponent of 3 plus 4x. And you cannot bring the 3 and the 4x together. They are not like terms. The 3 doesn't have an x. If it was 3x and 4x, then yes, you would have 7x. But in this case, no. It's just 3 plus 4x. That is all. In D, okay, I have a big number 512 in the denominator, and basically I'm going to change that to a power with a base of 2. So this is going to stay as 1 over for right now. 512 is actually 2 to the exponent of 9. So there's your 512, and it's still to the exponent of 3x. Okay, so this could actually be rewritten as 1 all over 2 to the exponent of 9 times 3 is 27x. Okay, but I need to bring that up to the numerator. So now this is going to be 2 to the exponent of negative 27x. Okay, and there's your simplified expression, and that base 2 is what I want. Okay. In the last one in this section, okay, right now my base is 16 over 81. I want that to be 2 over 3. So what I would do is I would take 2 over 3, okay, and think about how do I make 2 and 3 look like 16 and 81? Well, you would go 2 to the exponent of 4 and 3 to the exponent of 4. Both of those will give you 16 over 81. So there's your 16 over 81. It's still to the exponent of x plus 5. So again, a power raised to another exponent, you multiply the exponents together. So this is 2 over 3 to the exponent of 4 times x, 4x, and then 4 to the exponent of 5. So that's a positive 20. And there you go. So 2 over 3 to the exponent of 4x plus 20. Perfect. Okay, moving on. So now we are going to take those laws that we've learned and reviewed and change of base, okay, all those great things we did on the first 2 pages, and we're going to use them now to solve equations with rational exponents. Now again, remember, rational exponents mean that your exponent is going to look like a fraction, right? A number that has both a numerator and a denominator, okay? So let's read through the question here. It says the volume of a beach ball is 50,965 centimeters cubed. Determine the radius of the ball to the nearest tenth of a centimeter. And again, they're nice to you. They give you the volume for a sphere. In questions like this, they will provide the formulas for you, okay? They're not going to expect you to remember the volume of a sphere. So what you can see happens, it says Sarah and Lee are solving the problem. In the first 4 steps, their solutions are identical. So what they both do is the following, okay? Step 1, okay, write out the formula. Step 2, okay, substitute the volume in for V in the equation. Step 3, they multiplied both sides of the equation by 3, and then step 4, divide both sides of the equation by 4 pi, okay, so that r is isolated. Now the issue is that r is isolated, okay, this is true, but it's r cubed. We don't want r cubed, we want r. So let's take a look at what the 2 students did and talk about their calculations. Okay, so it says complete Sarah's solution. So again, she has r cubed equals that calculation. She wants r. So what she's going to do, and it tells you up above here, it says Sarah completed the solution by taking the cube root of each side. So what would happen is she would take the cube root of this side to get r. And if that's the case, she would have to take the cube root, okay, of the other side of the equation. So that means she's going to take the cube root of 3 times the 50,965 all over 4 pi. Okay, so when I do that in my calculator here, okay, and I round it to the nearest tenth, you will see that I get, and hopefully you can play along at home, okay, you get 23.0 centimeters for the radius. Okay, moving on to Lee. Lee says, or it says that Lee, I apologize, got the solution by raising each side to a specific power. So here's what happens. What Lee does is he takes this side of the equation, and instead of taking the root, he raises it to the exponent of 1/3. Now, why would he do that? Well, because when I have a power raised to another exponent, you multiply the exponents together. So if I take the number 3 and I multiply it by 1/3, okay, you're going to get 3/3, okay, which equals 1, which is what we want, r to the exponent of 1. But if I raise the left-hand side of the equation to 1/3, I must also raise the other side of the equation, okay, to the same exponent. So I'm going to raise the right-hand side of the equation also to an exponent of 1/3. And when you do that, okay, you will see that you also get 23.0, okay, and it was supposed to obviously work out that way. So the guy with the fake stop sign, okay, right here, okay, obviously says use the following procedures to solve an equation where the exponent is rational, okay, a over b, or has a numerator and denominator. Raise both sides to the reciprocal power. So reciprocal means 1/, okay? So if it's 3, you raise it to 1/3. If it's 2, you raise it to 1/2. And then simplify and solve for the variable. So that's what we're going to do here, okay? Those exact steps. So in A, solve for x in each of the following. So here's what happens, right? I have x to the exponent of -4/3. Now I want just x, so I'm going to raise the left-hand side to the exponent of negative and then the reciprocal, which is 3/4. So I raised the left-hand side to the -3/4, so I have to do the same thing to the right side, 81 to the exponent of -3/4. Now on the left side, you're just going to get x, because when you multiply those exponents together, you're going to get 12/12, which is 1. On the other side, though, you have 81 to the exponent of -3/4, so we know that we have to go 1/81 to the exponent of 3/4, okay? And what we've learned there is that when I have something raised to the exponent of 3/4, that's the same as taking the 4th root of 81 and then cubing that value. So the 4th root of 81 again is 3, and then you have to cube it. So this is the same as saying 1 all over 27. So there's the value of x. Okay. B, I need to get to this variable x right here. So what I have to do, okay, is eliminate this exponent of 3 over 2. Now, in order to do that, here's what I have. I have 3x minus 5 to the exponent of 3 over 2. So I'm going to raise the left-hand side of the equation to an exponent of the reciprocal of 3 over 2, which is 2 over 3. So if I raise the left-hand side of the equation to 2 over 3, I must raise the right-hand side of the equation to 2 over 3. So on the left-hand side, you'll just be left with 3x minus 5 because the exponents will work out to be 6 over 6, which is 1. And the right-hand side means I'm going to take the cube root of 27 and then square that value. So this is going to be 3x minus 5 equals, the cube root of 27 is 3, and 3 squared is 9. So then 3x will equal 9 plus 5, which is 14. And then divide both sides of the equation by 3. So 14 over 3 is the correct value of x. Okay, and that is it. Look at that. So much fun. Time flew by. Okay, so take a look at that for lesson 1 of exponents and logs, and see how you do working through the assignment. Okay, any questions, again, as always, feel free to contact me. I am usually pretty good and pretty quick at getting back to you with a worked out solution or some helpful hints as to how to improve your math performance there. And an evaluation test will be coming in the next week or so. I will update you with those dates on the Google Classroom, so please make sure that you are checking that regularly for more videos on lessons. And if you are one of the first ones to view it, or you see a note on test dates coming up, please spread those around or let the other classmates know about those dates and videos if they aren't checking regularly.